P equals P1, P2, P3 and so on is a set of points on a plane, no three of which are collinear. There exist 6 different circles on the plane, each of which has exactly 4 points from P on its circumference. Find n such that when P has less than n points, the given scenario is not possible. So we are told that if there are less than n points in P, then we cannot have 6 circles, each of which has 4 points. It's quite a hard problem to understand, so let's do a simpler version of the problem first. What if there are only 2 circles? If there are 2 circles, then the 2 circles can share 2 points, right? And so the minimum number of points we will need is 6. They can't share more than 2 points because 3 or more points define a circle. 3 points define a circle. So at the most, the 2 circles can share 2 points. And so the minimum number of points we will need is 6. The 2 shared points and 2 extra points for the 2 circles. How about 3 circles? Now each pair of circles can share 2 points. And you will get 4 points on each circle. So here the minimum number needed is 6. How about 4 circles? It gets very complicated here, right? It's quite hard to think about this problem in terms of points. That's because 2 circles can share either 0, 1 or 2 points. And each point, more importantly, each point can be shared by any number of circles. And that makes it very hard to track the number of points number of times each point has been counted. And so thinking about this problem in terms of points is not going to help us much. It may, but it's quite a complicated process. So what is less complicated? How about chords? We know that a single chord can be shared by at most 2 circles, unlike points, right? And since there's a limit on the number of circles that can share a chord, hopefully this will make our problem a bit easier. A chord is nothing but a line segment, right? Here it joins 2 of our points. Our entire system has n points. So let's track the number of line segments in our entire system. If there are n points in the system, how many line segments are there? It's nc2, right? It's just a matter of finding the number of ways of choosing 2 points out of n. Now no 3 of these points are collinear, and so these line segments will not overlap. So if we call the number of line segments in the system L equals nc2, that is n into n minus 1 by 2. But each line segment is either a chord or it is not, right? In this case, these 2 are chords and this is not a chord. So L equals k plus number of non-chords, where k is the number of chords. If the number of chords is k, then L equals k plus the number of non-chords. We have an expression for L. Let's try to get an expression for k, or a value for k. That is the number of chords in the system. Now the total number of chords, including the repetitions, is the number of circles times number of chords within a circle. This is 6 and this is 4c2. Because you can have 4c2 chords in each circle. It's just a matter of choosing 2 points out of 4. And this is 6, and therefore the number of chords with repetitions is 36. Of these, some of the chords are shared, and so they are counted twice, right? So we will need to find out what is the maximum number of shared chords. The maximum number of shared chords is basically the maximum number of pairs of circles, right? Because each pair of circle can share a chord, and so if every pair of circles in the system share a chord, then the number of pairs equals number of shared chords. And the number of pairs is 62 because it's a matter of choosing 2 circles out of 6. That is 15. So at the most we can have 15 shared chords. And of these 36, these 15 are being counted twice. So we need to subtract 15 from 36 to get the number of chords in the system. This is the minimum number of chords, right? Because if the number of shared chords is less than 15, let's say 12, then the number of chords would be 36 minus 12, 24, right? It will be larger than 21. 21 is the minimum number of chords in the system. The system should have at least 21 chords. So we have the minimum value for k. Now we saw that L equals k plus the number of non-chords. The number of non-chords cannot be negative, it's either 0 or positive. And therefore k plus something positive is L, and therefore L must be greater than or equal to k. But we know L is n into n minus 1 by 2. We are trying to find the minimum value for n, and n will have the minimum value when L has its minimum value. And the minimum value of L depends on the minimum value of k, because L is greater than or equal to k. Right? So n into n minus 1 by 2 must be greater than or equal to 21. K is 21. Or n into n minus 1 to n into n minus 1 is greater than or equal to 42. And therefore n must be equal to 7. Anything less than 7 and n into n minus 1 will not be greater than 42, greater than or equal to 42. When n is 7, we find that 7 into 6 is 42. It's equal to 42. And therefore, if the number of points is less than 7, then we cannot have 6 circles with 4 points each.